So in order to find the center of mass for this unit cube, we have to remember the equation, the lovely equation, density equals mass over volume. And here they give us the expression for density. And so because density at point xyz is proportional to the square of the distance between the origin and that particular point, that expression can be written as this. P of x comma y comma z, so that's the function of three variables, is equal to some constant times x squared plus y squared plus z squared. And so this expression here shows us the shows us the density of any given point within the unit cube. And since we know that density equals mass over volume, we know that mass equals density times volume. And we've determined earlier that we use triple integration to determine the volume of any kind of shape or object in three dimensions. And so that triple integral can be expressed by this volume, by volume here, and we've determined the density with the given information. So that density, the density here will be expressed by this equation. And so using all of this information, we can determine that mass is equal to the triple integral, which is essentially the volume, of the density, which we determined here is k times x squared plus y squared plus z squared. And then we're going to integrate it, I don't know, dz, dy, and then dx. And so this is our expression for mass, because we know that mass equals density times volume, which is determined by the triple integral. And so in order to determine the limits of integration, or the lower and upper bounds of each x, y, and z axis, we can take a look at our graph. And I said earlier that all of these points go up to 1. And so our lower and upper bounds for each z, y, and x will just be 0, 1, 0, 1, 0, and 1. And so this is the expression for finding the center of mass of the unit cube.